So Meta just dropped something pretty massive in the AI world. Or maybe I should say a whole herd of massive things. You guys know how the context window race has been heating up, right? Well, Meta might have just completely reset the competition with their new LLaMA 4 lineup. Let's dig into this because it's more than just one model. Alright, so Meta announced the LLaMA 4 herd. They're framing it as a family of models, and right off the bat they've introduced three key players. LLaMA 4 Scout, LLaMA 4 Maverick, and the giant LLaMA 4 Behemoth. Let's start with Scout, because honestly this one is kind of blowing my mind, because the headline number here is simply staggering, 10 million tokens. I really want to emphasize how massive this is. For years, context windows were a major bottleneck. Early models could only handle a few thousand tokens, roughly equivalent to a few pages of text. Then we saw jumps to 32K, 128K, 200K. Google's Gemini 1.5 Pro hitting 1 million tokens earlier this year felt like a monumental leap, opening up possibilities like analyzing entire code bases or long videos. Scout multiplies that state-of-the-art figure by 10. What can you do with 10 million tokens? Let's try to visualize it. It's roughly equivalent to the entire text of the 7 Harry Potter books combined, maybe twice over. Or think about processing all of Shakespeare's known works in a single prompt. In a business context, imagine feeding it years' worth of customer support transcripts to identify deep underlying trends or pain points. For researchers, it could mean analyzing vast datasets of scientific literature or genomic sequences. For developers, it's the dream of having an AI assistant that can understand the entirety of a complex, multi-repository software project, offering insights or debugging help with full context. For personal use, imagine an AI tutor that has read every textbook you're using, or a personal assistant that remembers every conversation, preference, and detail you've ever shared, leading to truly hyper-personalized interactions. The potential is immense, but it also raises questions. How did Meta achieve this? They point to a combination of factors. Architecturally, like all the new LLaMA 4 models, Scout uses mixture of experts. As we discussed, this means it has a large total parameter count, 109 billion for Scout, but only activates a fraction of those, 17 billion active parameters drawing from 16 experts, for each token processed. This sparsity is key to making inference computationally feasible. Imagine trying to run a 109 billion parameter dense model, where all parameters are active, on a 10 million token input. The compute requirements would be astronomical. Mo provides a path to scale total knowledge capacity, while managing the active computational load. Meta also highlights specific technical innovations for handling these ultra-long sequences. They reference using interleaved attention layers without positional embeddings, and a technique called inference time temperature scaling of attention, bundled under the name IROPE architecture. This sounds complex, but the core challenge with very long context is twofold. Firstly, the computational cost of the attention mechanism itself, and secondly, the model's ability to actually pay attention to relevant information across vast distances without getting lost or forgetting earlier parts. Traditional positional embeddings, which tell the model where a token is in the sequence, can struggle at extreme lengths. Meta seems to have developed novel techniques, likely modifications or extensions of existing methods like rotary positional embeddings, ROPE, combined with clever architectural patterns, interleaved layers, and dynamic adjustments during inference, temperature scaling, to maintain focus and manage compute over these unprecedented lengths. Meta claims Scout is highly efficient, suggesting it can run on a single NVIDIA H100 GPU. While an H100 is a beast of a chip, costing tens of thousands of dollars, running a 10 meters context model on a single such GPU is still a remarkable feat of engineering and optimization. It brings this capability closer to the realm of practicality for organizations or researchers who might have access to high-end hardware but not necessarily massive distributed clusters. Okay, let's shift gears to LLaMA 4 Maverick. If Scout is the marathon runner specializing in endurance, Maverick is more like the versatile decathlete, strong across multiple disciplines, particularly multimodality. Maverick comes with a 1 million token context window, still very large and competitive, matching Gemini 2.0 Flash. Its core strength, however, lies in being designed from the ground up to understand and process information beyond just text. Meta emphasizes its native multimodality, capable of handling images and video frames alongside text inputs seamlessly. It achieved this through early fusion during pre-training, integrating visual and textual information deep within the model's architecture, rather than treating vision as an add-on. They also mentioned specific improvements to their vision encoder to better align it with the language model's representations. Like Scout, Maverick is an MO model with 17 billion active parameters. However, it draws from a significantly larger pool of specialists, 128 experts compared to Scout's 16. Meta positions Maverick as a performance powerhouse, especially considering its efficiency. They claim it surpasses models like GPT-4o and Gemini 2.0 Flash on various benchmarks covering coding, reasoning, multilingual capabilities, and image understanding. The benchmarks cited include challenging ones like MMU, MathVista, ChartQA, and DOCVQA. Perhaps most tellingly, Meta claims Maverick achieves performance comparable to the new DeepSeek V3 on reasoning and coding tasks, while using less than half the active parameters. This is a direct shot emphasizing Maverick's efficiency, achieving top-tier results without needing the massive active compute footprint of some competitors. If true, this makes Maverick incredibly attractive. Furthermore, Meta shared an experimental chat version of Maverick, achieved an ELO score of 1417 on the LMSYS chatbot arena leaderboard. For context, this puts it squarely in the territory of leading proprietary models like GPT-4o, Claude 3 Opus, and Gemini Advanced, indicating very strong conversational ability and user preference in blind head-to-head comparisons. The implication is clear. Meta wants Maverick to be the go-to model for developers building sophisticated AI applications that require understanding the world beyond text. Think advanced visual assistants, tools that can analyze complex diagrams and reports, platforms that can generate rich media content, or educational software that integrates visual aids seamlessly. Its combination of a large context window, strong native multimodality, top-tier benchmark performance, and purported efficiency makes it a very compelling offering. They also claim it can run on a single NVIDIA H100 host or distributed inference for maximum efficiency. Now let's address the elephant in the room, or rather, the Behemoth. LLaMA 4 Behemoth lives up to its name. Meta revealed it has nearly 2 trillion total parameters. This places it among the absolute largest AI models ever discussed, potentially exceeding the speculated size of giants like GPT-4. Even with Mo, Behemoth operates at a massive scale, featuring 288 billion active parameters. That active parameter count alone makes it significantly larger than most publicly available models. However, Meta isn't planning to release Behemoth for public download, at least not initially. Its primary role, as described by Meta, is to serve as an internal, quote, teacher model. It's the ultra-intelligent, knowledgeable powerhouse used to distill its capabilities down into the smaller, more efficient student models like Maverick and Scout. So that's the behind-the-scenes powerhouse. But speaking of what is out there for the community, a core pillar of Meta's AI strategy has been its approach to openness, and LLaMA 4 continues this trend. They've released the weights for LLaMA 4 Scout and LLaMA 4 Maverick on platforms like Hugging Face and their own website, allowing researchers, developers, and businesses to download, modify, and build upon them. By providing cutting-edge models like Scout and Maverick, Meta keeps the developer community engaged within its ecosystem. Meta is also trying to address the safety concerns inherent in releasing powerful models. They offer tools like LLaMA Guard, Prompt Guard, and Cyber Sysevil. Furthermore, Meta addressed the issue of bias, acknowledging that LLMs historically tend to reflect biases present in internet training data. They claim LLaMA 4 makes significant strides here, refusing fewer prompts on debated topics overall, down from 7% in LLaMA 3.3 to less than 2%, being more balanced in which prompts it refuses, less than 1% unequal refusal rate, and responding with strong political lean less often. Their goal, they state, is to create models that can articulate multiple viewpoints neutrally. This commitment to addressing bias, alongside the safety tools, is part of Meta's attempt to balance openness with responsibility. So what's the big picture takeaway from the LLaMA 4 announcement? Meta has made a powerful, multi-pronged statement. They're pushing the absolute boundary on context length with Scout, delivering a highly capable and efficient multimodal workhorse with Maverick, and leveraging the immense scale of Behemoth internally to drive quality across the board. This move will undoubtedly force competitors to react. There are still many open questions, particularly around real-world performance, the true usability of the massive context window, and the practical implications of the efficiency claims. But one thing is clear, Meta isn't just participating in the AI race. With LLaMA 4, they're actively trying to change the rules of the game. As always, thank you so much for tuning in and sticking through this deep dive. If you found this analysis valuable, please hit that like button. It really helps the channel. And consider subscribing for more in-depth coverage of the latest in AI and tech. Stay curious, and I'll see you in the next video.